All right, welcome everyone. This is the Platform 9 Ask Us Anything session focused on telco, 5G, 4G equipment on Kubernetes. We're just going to hold for a couple of minutes before we kick off, give everyone a chance to dial in, give a chance for everyone that's on the West Coast like I am and making their morning coffee and still getting their day started. So won't just be 2 or 3 more minutes and then we'll get started. Thank you everyone for dialing in. If you're just getting connected, we're just going to wait 1 or 2 more minutes before we start today's Ask Us Anything session on telco, 4G, 5G equipment running on top of Kubernetes. All right, everyone, I think we are going to get started today. Thank you all very much for making time. This is a continuation of the Platform 9 Ask Us Anything web series. We're here every 2 weeks. My name is Chris Jones. I'm the group product manager here for Kubernetes at Platform 9. And these sessions are meant to be open, interactive. So we do encourage, please ask questions. You can send them through in chat. You can jump in Slack, send them through. Also, feel free to raise your hand and we'll unmute you. If we are going to do that, we do ask that we limit people's questions to 1 or 2, just so we can make sure we cover everyone's questions. Everyone gets a fair amount of time to seek the answers to their own questions. So with that, I'm going to hand over to a fellow product manager here at Platform 9, Rohan, as well as one of our solution architects, Madit, who is a fairly well versed in the 4G, 5G world. And we're going to have a brief chat about 5G and telco, and hopefully we start seeing questions flowing in and we can help get all of you going and also cover off how we help telcos around the world run their 5G equipment. And with that, I'll hand over to Rohan.
Thanks, Chris. Hi, everyone. As Chris mentioned, I'm a product manager here at Platform 9, and I work with our team on our Kubernetes stack for 5G and telco customers and partners. So we've learned a fair bit working with customers and partners along the way in what 5G and telco is all about, as well as how 5G and telco applications benefit from running on Kubernetes-based infrastructure. And so I want to go over, I don't have a huge deck here. I think really the point here is to foster discussion. So I want to go over some of the basics just to level set, and then start getting into things, an overview of things that we've learned. And then at some point I'll hand it over to Mudit, who will actually get into the more exciting part of the session, where he's going to show a demo of 5G packet core. So with that, let me get started. So first and foremost, like I said, just to level set here, let's talk a little bit about 5G deployments and what they entail. So really, this is a 10,000-foot view, but what it's trying to communicate is in 5G, the types of applications that are in some ways promised to be supported are things like connected cars, performance sensitive applications, machine learning at the edge. It spans this wide spectrum of applications really beyond just 5G on your mobile phones. And to make this happen, to make all of these different applications possible, let's take a look at 10,000-foot view of what the 5G deployment actually looks like. What are the different components? So near the edge devices or the user equipment, things like mobile phones, connected cars, you get the picture. There's an access network, which essentially, popularly called a RAN, radio access network, which lives very close to the edge. Latency between the edge device and the access network would be pretty small, and there would be some sort of processing done there. The packets then go to this aggregate edge, which could be a co-location site, and is a site where there's a little more processing power, a little more. It's sort of an intermediary, right, between the edge and the actual core network. And then finally, you have the core, which could live on a public cloud. It could live on a data center. It could live, really anywhere further away from the end user device. And most of the processing is done there, right? So that's kind of the types of networks that it spans. But the interesting part is to actually get into what the stack would look like. And if you take a step back and look at the telco business as a whole, there are different types of capabilities or functions that actually need to be supported in these different networks. So for example, you see, here in the application layer in the second row, you see OSS, BSS. What is that? Well, it turns out that a lot of these functions span the business side. So for example, if you're a telco provider, how do you take orders? How do you do customer management? All of these things that are actually generally applicable to any other business, those need to be made available on the telco stack. There's also the operations side, right? So once an order is taken, how do you actually process it? So all of these different aspects of the business and the operations side, all of that needs to be made available as a part of the as a part of the 5G or as a part of the telco stack, right? We haven't really, this is applicable regardless of 5G. In addition, another sort of nuance on the telco side is that the way it works is there are infrastructure providers, and then there are communication service providers that consume infrastructure. And then communication service providers will have a set of MVNOs, which is mobile virtual network operators, who end up consuming slices of the telco network that is made available to them by the communication service providers. So an example of this is Cricket is an MVNO, and it's using a network slice off of either AT&T or T-Mobile, I actually forget, but one of them, which is the CSP that provides a slice of the network. So now that's on the business side, right? Now, if you take this back and if we try to figure out what do we need to support from a technology perspective, and I'm not going to get into the details of network slicing and so on, but just from a high level, if we need to support those kinds of things, which is multiple MVNOs that need to consume slices of networks that are exposed by CSPs, how do we make this happen, right? So there are the answer is that there are network functions, which essentially are it's basically logic that's running on the communication infrastructure, which makes it possible to slice out the network and provide isolated end-to-end slices of network resources to each of these end consumers, which are MVNOs, an example being Cricket. So in order to support all of this, these are really all applications, right? And in order to support all of this, There needs to be an infrastructure lying underneath that can handle, can not only handle the kind of scale that is required for this, but also provide things like, flexible deployments, scalable deployments, and just ease of management, right? Because as you can imagine, this is going to be sprawled. This infrastructure and these applications are going to be sprawled geographically and are going to be, in terms of scale, there's going to be a lot of scale, right? So going back to the stack that's on the slide here, it starts off with network slicing at the top, and then there's the OSS, BSS, and all these applications that's running on. Underneath that is the telco cloud layer. And this is where things like config management, as well as specifics related to where it's running, like, for example, is it in the RAN, is it in the core? That's those are the specifics that are handled by that layer. And beneath all of that is the platform, right? What is all of this? What are all these applications running on? Now, historically, right, back in the day, maybe 10 years ago or so, in the telco space, all of this was supported on specialized physical appliances. And so in terms of flexibility, in terms of scalability, in terms of cost and how often you needed, how often you could actually replace things, there wasn't really much flexibility, right? Or scalability. And when virtualization came along, a lot of that functionality started getting implemented on top of a virtualization layer. And that's kind of where it exists today as companies start building out 5G stacks, which is a lot of it is running on VMs, and VMs actually ended up offering the kind of flexibility and scalability that physical appliances obviously didn't. But now, as 5G stacks are being built out, there's an opportunity to re-architect things and re-innovate and use more recent technologies. And Kubernetes seems to be at the forefront of that because of the various different benefits that it provides. And we'll get into that in just a bit. But the fourth layer here, platform as a service, you can see there are things like service mesh, gateway, right? How do you access the interest, how do you make it so that the applications can access endpoints outside of their local networks, and how do you provide the kind of connectivity it needs? How do you monitor what's going on, right? The kind of resilience, the kind of downtime that's tolerable is very little, as we've learned, working with our partners. And so you need ways to monitor it, and you need to manage all of these systems, right? Underneath that, you could, like I said, you could run virtualization software, right, which is enabled in multiple different ways. It's pretty mature at this point. But with Kubernetes, there's the option of also deploying these applications on containers and pods. I'm going to get into that just very soon and talk about the kind of specifics that need to be supported on Kubernetes in order to have these applications run in a way that's acceptable. And then finally, all of this needs to run on hardware, right? So you still need to manage the bare metal. This is just sort of the same stack, but visualization of the 5G core specifics, right? So there's a control plane and a data plane. Each of these two planes need their own functionality. So we'll talk about SRV, DPDK, which are needs for the data plane. And then this is the 5G RAN architecture. I know this is pretty, there's a lot going on in this slide, so I'm just going to hover over it, but it's just to give you an idea of, the intricacies. I was really talking at a 10,000 foot level, but the minute you go a little deeper, you realize that there are a lot of nuances and details and, new terminology, in fact, even. So now that we've sort of covered, what, like the basics of a 5G deployment, the business side, how that correlates to the technology, the rest of my slides aren't, they're literally going to be like this because, I'm just trying to foster conversation rather than present something. So why Kubernetes for 5G? As I was saying, historically, the telco stack has moved from physical specialized appliances to virtualized infrastructure. Now with 5G, there's an opportunity to re-architect, and the benefits of Kubernetes are actually universally applicable, right? It really doesn't matter what application you're running. And benefits of Kubernetes include things like an evolving and maturing ecosystem, right? There are several different projects around Kubernetes. An interesting one is KubeWort, which I'll just talk about later as well, which makes it possible to run VMs as a part of Kubernetes clusters, right? So all of a sudden, moving to Kubernetes doesn't just mean containerizing everything. It could mean having some sort of hybrid scenario, right? So there's a really interesting and evolving ecosystem around Kubernetes. Kubernetes makes it very simple to automate your infrastructure and operate it with the kind of ease that hasn't really that's kind of much better than what previously was exposed. One example of this is declarative interfaces, right? So with Kubernetes, Kubernetes is based on entities like operators, which essentially make it easy for you as an operator to specify a desired state, and then the operator, which is just something running on as a part of your infrastructure, as a part of your Kubernetes cluster, will monitor what your desired state is and monitor what the actual state is, and then bring the actual state to be equal to the desired state. So you don't really need to sort of tell it what to do. You just need to tell it what you want.
Yeah.
Right. So,
Rohan, we've got a question in the chat. I know Madid has sort of answered it in the I guess the panel section here, but I think it'd be a good topic to talk about is handling the coexistence of different containerized network functions from different vendors.
What exactly is the question? Sorry, I'm actually presenting on my screen, so I'm not able to see it.
Yeah, no worries. I thought that might be the case, so I thought I'd jump in. So Sudeep has asked, how do we handle the coexistence of different 5G C and Fs from different vendors? So imagine a Ericsson or Nokia, and their different containerized network functions running within the same Kubernetes cluster. I know Madid has mentioned namespaces as one way to achieve this, and I think that's a fairly common way of breaking up a Kubernetes cluster and isolating application functions. But it'd be good to explore that a little bit further, Madid.
Yeah, Madid, if you want to take that.
Yeah. Thanks, Chris. So definitely there could be like multiple ways to do that, like existence of multiple vendors, CNS. So one way is definitely like we can have a namespace kind of concept where we can have a RBAC rule. So one tenant can only see his own namespace. So we can deploy whatever like CNFs in that namespace, and let's say like, so that is like, let's say vendor Ericsson, and similarly there is another vendor which is Nokia. So I can have another namespace as a telco operator. I can have another namespace, and with the help of RBACs, I can have certain rules where like I cannot see the other namespaces or other applications. So in that case, Nokia vendor can do that. So that is like one way. There could be other ways, like we can have multiple clusters also, and maybe using some kind of service mesh. Maybe if it is required to like if we require to communicate the CNFs across the cluster, then we can definitely go with that way. So but I think the easiest way right now is the namespace. But once I'll give you once I give you a demo, maybe I can showcase like even how in Platform 9 how the users are there and how can we do the archive things. So
yeah, there's another question that came in that I think is a pretty good question. I'm happy to jump in on this one as well. It says, how will Platform 9 manage all of the CNF observability, tracing, logs, metrics from a single console? I think that's a great question. For people that are new to Platform 9, we operate a SaaS control plane, which is able to remotely deploy, operate, upgrade, destroy, and apply self-healing and resiliency capabilities to Kubernetes clusters running really anywhere. We have a bare metal product, a virtualization product, and obviously our Kubernetes platform. And by leveraging our SaaS control plane, we'll deploy and operate those remote clusters. Built into that is a Prometheus Alert Manager and Grafana stack that looks at the health of that cluster internally to it. And we also have elements that sit on the external to that cluster as well, that are looking at the health of all those Kubernetes components. That data is reported back to the SaaS management plane. And if there's an issue, our enterprise support team will be notified of that. Users will also receive email notifications of any issues that are impacting their cluster from that external monitoring. The internal monitoring will also propagate data up into the SaaS management plane where you can consume information about alarms and events about the cluster. When it comes to the telco pieces itself, I'll let Rohan describe how we're working on that with our partner that we're doing a lot of development work with.
Yeah, so basically, in addition to what Chris just said, yeah, I just want to make sure I'm not on mute. In addition to what Chris just said, we're also about to release an air-gapped version of Platform 9. So what this would mean is that we work with our partners and give them the ability to manage Kubernetes for their customers. And a lot of the the tooling and the way that Chris described, we monitor at the back end. A lot of that is actually being productized in a way and given to our customers. So that when issues happen, the tooling will sort of help our customers understand that there's an issue quickly and then be able to resolve it.
Yeah, if you're looking for specifics of observability and tracing and logs, we're in the process of making our Fluentd operator generally available, which will help get logs out of your containers and send them to a predefined destination. If you're looking for tracing and metrics, Prometheus is something that's getting a lot of open source and standardization built into it. So building in endpoints to your network functions is a great way to then be able to leverage a existing Prometheus installation. If you're looking for tracing, there's projects out there like Jaeger. There's also service mesh capabilities that you can layer over the top. We're not going to specifically get into collecting the data and displaying that data from an operational side of the CNF. That's where we work with our partners as well as other telco vendors to ensure that enterprise layer of monitoring, which should be really an external, highly available and resilient platform that can take all the distributed data in together, is external, as I said, to the management plane and the clusters, as well as external and not dependent on any of the infrastructure that's running those CNFs. So we really rely on the vendors to build that capability into the CNFs, and then for the operators to have a available enterprise monitoring capability that all that data can be consumed and brought into. So we'll look after the clusters externally. We'll give you the ability to understand what the cluster is doing internally, and then from that application layer up, we'll work with what the vendors are providing and what you have running in your environment today. And then we've got a good flow of questions coming in, Rohan. Do you have anything you want to add to that topic, or should we move on?
No, I think we can move on.
Yeah.
Awesome. So the next thing is challenges with running 5G on Kubernetes, right? What have we learned along the way? So the third one here is something that I really want to touch on, which is that these VNFs require certain capabilities and certain, they're performance sensitive in some ways. And so there were some specific things we needed to support and we needed to make easy for our partners and customers in order to be able to run these network functions on Kubernetes. Some examples are SRIOV, MAC VLAN, IP VLAN, as well as DPDK, right? In order to give the virtual functions the kind of performance that you would get if you were not on a virtualization or containerization platform, right? And so there, the idea here is that you can configure a host for SRIV or MAC VLAN and so on. You can do it manually, right? But to do that at scale and to do that, across the deployment, one by one or manually or in some other way, it's there's work to be done there, right? So one of the things that we've been working on in order to make it easier for our customers and partners is basically a network, is basically a Kubernetes operator that we call Luigi, which, or actually that's an umbrella of operators that makes it easy to understand the capabilities supported by hosts. So SRIV is an example of this. Is the host SRIV capable, right? Now, if I have a deployment of hundreds or thousands of hosts, what this will do is it's a custom resource in Kubernetes, which you can then use in order to, which you can deploy, or it's a plugin, sorry, which you can deploy and get the state of each of the hosts and get their OS and hardware specifications. And then we also have an operator that makes it easy to configure networking related stuff on the hosts. So SRIV, again, I'm going to take the same example. If I wanted to configure SRIV on the hosts, then I could use this operator under this umbrella we're calling Luigi in order to do that. The other thing, and I can get into that a little later, I have a couple of example YAML files that I can show you where you just need to edit the YAML file, and the rest of it is automated by the operator. So all of your hosts will be, will get the SRIV configuration that you specify in the YAML file, for example. The other thing is at scale, we realized that centralized management. Sorry, was someone saying something? Okay, so at scale, we realized that centralized management is extremely important. In fact, one of the partners we're working with is looking at, thousands, approaching, between 5,000 and 10,000 nodes, geographically apart, of course. And so we're seeing a lot of value in having a centralized management plane, right? Something where you can deploy it, and then no matter how many nodes there are, you can, have multi-tenancy. You can, basically go to the centralized management plane to understand the health, as well as perform operations on your deployment. So that's another one that had a lot of sort of value. IPv6 is something that we're seeing is needed to be supported at the Kubernetes cluster level, at least. And then finally, another challenge was one network per pod, right? Which is the primary network interface exposed by, by a pod in Kubernetes. That's not enough, right? A lot of these network functions require more network interfaces. And, thankfully with Kubernetes, like I said, there's this ecosystem, and there's a project called Multis, which makes it possible, which is essentially, like a multiplexer, and makes it possible to add multiple different CNI plugins to a pod, so you can have multiple network interfaces. So Platform 9, just to connect the dots here, provides a managed version, provides Multis as a part of Platform 9 managed Kubernetes, supports IPv6 in the Kubernetes cluster, as well as does that automation magic that I talked about, which makes it really easy to actually deploy Kubernetes clusters that support network functions. So we're kind of at the halfway mark, and I did want to, there's more stuff we can talk about, but I did want to, hand it off to Mudit for, his demo of the packet core, which I wanted to make sure that we go through today.
Yeah.
So Mudit, do you want to take over?
Sure. Yep. Thanks, Ron.
Yeah, I was also going to say there's a really good question. I think it would set the stage well for this demo that's come in. asking about deployments that might require containerizations or virtual machines or bare metal, and can we support that type of hybrid deployment model in Platform 9?
Yeah, I would love to answer that question. So the answer is absolutely. In fact, that's something that we're seeing is needed, right? So not everyone is containerizing everything, but yet Kubernetes has its advantages, and so organizations do want to adopt Kubernetes, right, and containerize some things. And so what we're seeing is the need for that optionality where you can run containers alongside VMs and run them on bare metal if you want, right? And really the difficulty here is that these are different stacks, right? If you just look at it, there's a virtualization stack, there's a containerization stack, and then there's managing bare metal. And all of this is pretty complex. So we realized this problem, some time back, and as I was mentioning, there's this project in the Kubernetes ecosystem called KubeWort, which makes it possible to run VMs as a part of Kubernetes clusters. So essentially, you don't need to maintain a separate virtualization stack anymore, technically speaking. You could install KubeWort and then create VMs and really just manage them. It supports things like live migration and all the other basic necessities of a virtualization platform. So you can create VMs as a part of Kubernetes clusters running alongside containers today using KubeWort. And so we decided to adopt that philosophy and support KubeWort in a SaaS managed way. So we have an early access going on, but we're well on the path to a GA of our managed KubeWort product, which essentially will make it possible for you to create Kubernetes clusters on Platform 9, just as you do today. And then also deploy VMs on those clusters. So single management plane, but the optionality of virtualization and containerization. Now on the bare metal front, Platform 9 also late last year announced the general availability of Platform 9 managed bare metal, which essentially is a productized version of Ironic. So it's OpenStack Ironic exposed in a SaaS managed way. So all the benefits that Chris was talking about earlier about our SaaS management plane, things like management, from a management control plane, Platform 9's expert support available 24/7, 99.9% uptime SLA. All those things carry over to our bare metal automation product, and essentially you can use that product and use the SaaS management plane once you've done the initial deployment to deploy images to your bare metal. You can update them, you can change them at any time. There's discovery of nodes in the network. So once you've done the initial deployment, the ongoing, day two onwards operations of your bare metal is fully automated. So in that way, you can sort of focus on the business, and a lot of these complexities are taken care of. Chris, I don't know if you want to add anything to that.
No, I think you covered it really well. We are really targeting edge, and that really does help with a lot of 5G deployments. I think it'd be good to get into Madit's demo about leveraging Platform 9 and getting a full stack up and running. And then we're going to jump into some other questions around geo redundancy, and I think that will be the next one after the demo. Let's do it.
Yep. Yeah, thanks. Okay, so hi everyone. So my name is Madit Chen. So today I was asked to showcase a demo where I can run a 5G core on Platform 9 managed Kubernetes cluster. So for today's demo, I will be using a free 5GC solution actually for 5G core. So that is what I'll be using. So just let me share the screen. Right. I can see my screen. So this is the Platform 9 management plane. So here you can see I have some multiple clusters being kind of running. So right now we are interested into this 5G core cluster, Kubernetes cluster, which I have already created. So here, if you see, I have I have one worker node and I have one master node. And this cluster right now is backed by this cluster is backed by Calico CNI. So I have a Calico CNI running, and this cluster is backed by that. So in this management plane now, you can see like there will be you can see all the cluster, and even you can see all the different workloads which are running across multiple clusters. So if I had to select my cluster, which is Demeter 5G core, and I could have selected the namespace where like I'll be running all the 5GC core components. So okay, so without any further ado, maybe let's jump onto the terminals actually. So I have this 5G master, and before we just like jump onto the actual thing, so as like Rohan was explaining on the cube word part, so I'm actually gonna leverage the cube word. So in the 5G we have two planes actually. We have the control plane and we have the data plane, right? So if I have to show here, so we have this is a 5G service-based reference architecture. So the top part is the control plane and the below part is the data plane. So I'll be running all the control planes as a pod. So these are all running into the Kubernetes cluster. But UPF, I'm running into a VM, and that VM is created using KubeVirt, and that is running on top of Kubernetes cluster. So that is I just want to kind of bring up that. So I'm onto my master node, and I have a namespace called free 5GC, which I have already created. So I have a namespace called free 5GC, and I have already created a VM. So if I do kubectl get VMIs, I can see there is I have created Ubuntu VM on which I have already installed UPF, and this is running, and this has got a IP. So this is coming from KubeVirt. So if we see, I have pods running for the KubeVirt in my cluster. So this is how like KubeVirt is kind of enabled into the platform in Kubernetes cluster. So with the help of this KubeVirt, I have already created a UPF VM, and in just interest of time, like to show the things. So I have the pods already running uh, in my free 5G namespace. So you can see these all are like all the control plane, be it AMF, ESF, or NRF. So all the control plane has been installed onto this one. So and if I have to go to the VM, so this is my UPF VM. So if you see the IP for this is 28, and this is the same IP which I'm seeing from kubectl VMI is the same IP. So I'll be starting UPF into this VM. So let me start the UPF. And just for this demo, I'm not using any SRIV or DPDK as such for this UPF. It's just like I did not need any such like exactly the kind of packet processing right now for this demo. So I'm not leveraging all SRIV or DPDK stuff as of now, but that can be done. Even we can attach a SRIVF to a Kubernetes VM or even to the pods. So that's what Rohan was explaining a few minutes back. So I have that UPF running, and what I'll do is I'll try to register the SMF with this UPF. So I'll delete the existing SMF which is already running, so that I can again create a PFCP connection with the UPF. So I think we should be seeing a PFCP association happening. So the SMF pod got created again. So I have a SMF pod again up and running. And if I go and check the logs inside the SMF pod, I can see it will show me that there is an association happen between UPF. So now I have an association with the UPF. What I'll do is, just in interest of the time, I'm not gonna deploy all the components again. So it's already installed. So I'll keep the AMF logs maybe open so that So I'll just make some space. So what I'll be doing, I'll be doing a UE registration. So I'll be just running a simple scenario for that. And I'm again using the free 5GC test cases to simulate that. So let me just run that. So we'll be seeing in the logs like all the associations happening. So if I run it, so we see all lot of thing in the AML. With the platform 9 Kubernetes cluster, we have also enabled the SCTP. So you can see I have this SCTP request coming from my UE actually. So it accepts the SCTP connection. It create a then it do a ng setup request and response will happen. Then authentication will happen. So then the SMF will be discovered and the UE will be registered. So this is how I just simulated a simple UE registration flow. And to showcase more here, so let's say, so what I was doing is if I have to see the services, so here if you see AMF is using the SCTP services. So I'm not using TCP, but I'm using SCTP connections for AMF. So this is like an interesting time. I'll just like give a small demo, and this is a way like we can deploy any other vendors CNF. So this is like one of the CNFs coming from 5GC that we can deploy any vendors. So and which can be managed through our single pane of glass and through the management plane. Yeah, so that's it for my demo. Any questions, maybe?
Cool. That's exciting. So that setup you had running was running KubeVirt inside the same cluster, a VM running some components, and then other pieces were the containerized network functions?
Yes.
Excellent. And you're using Multis within that to also enable, is it SIOV in that stack you had deployed, or DPDK?
Yeah, so I'm not like use the SRIV or DPDK functionality as of now, so I did not require that, but definitely we can go ahead and use that in our clusters.
Excellent, excellent. I'm going to touch on the geo redundancy. There's a question that came in from Stephen. Can a cluster be constructed with geo redundancy? Would want pods to be scheduled on a cluster of components in one geo, and only if that cluster were to fail, maybe some percentage of nodes are non-viable, will pods be scheduled in the other geo? How much resiliency can Kubernetes support? I think that's a really good question. I'm going to touch on one piece up front, just around the control plane within Kubernetes. So when you create a cluster, there is a redundant control plane. It's a set of nodes between 1 and 5. Obviously, for quorum, you need more than 1 for resiliency. 5 having the highest amount. The way that those control plane nodes talk to each other, they can be greatly impacted by round trip time and any latency issues. So splitting a cluster across multiple geographic locations can really result in unwanted behavior at the application layer and really degraded performance. That's generally something that we try to steer away from. In terms of application resiliency, cross-cluster service mesh is one of those concepts that's definitely worth exploring to achieve that level of high availability and resiliency. I'd like to hear input from other people on the phone. Rohan, Madeep, I'm not sure if Rupak managed to jump in as well and cover that point a little bit more.
Yeah, so I would just add that in order to have that kind of cluster level resiliency, you would have to build some sort of orchestration on top of a management plane like Platform 9, right? Where you have a management plane that's actually orchestrating all of the clusters and exposing interfaces to allow you to do that kind of orchestration. So it's not something that we have out of the box, but something that you would have to build on top.
Excellent, excellent. There's also a comment that came in from one of the users just on the questions for multi-vendor CNF, and Raphael was also saying that from his perspective that it would likely be best to have dedicated clusters for each vendor. Just from a support perspective, he thinks that that could also provide a better flexibility and greater fault isolation across multiple vendors in one customer environment. I think. Thank you for sharing, Raphael. That's a really important part when architecting platforms with multiple different vendors, and thank you for contributing. Let me see if there's other questions that have come in at the top. I'm not seeing any. It'd be great to see if there's more questions out there from the team on the line. If not, are there? Here's a good question for Rohan and team. If a 5G core is deployed in the cloud, what advantages do we get with Platform 9 over AWS? Rohan, are you happy to handle that?
Yeah, sure. So Platform 9's, if we just take a step back, Platform 9's vision is to provide, is basically that there's value in having a cloud operating model, no matter where your infrastructure lives, right? And I think that 5G is a great example of infrastructure that is going to be hybrid, right? Because there's going to be RAN, there's going to be infrastructure that's closer to the edge, and then there's going to be the core. So, no doubt you can run the core on the cloud, right? But at the end of the day, the entire infrastructure is going to be hybrid. And in working with folks that we're working with, we've learned that there's value in being able to manage all of that from, I don't want to use the overused term single pane of glass, but just sort of, a management plane that has a view on all of these distributed deployments, right? So as infrastructure gets more and more distributed, the value of operating it with a single model, right? In terms of automation, in terms of just having an overall view on the different pieces of your infrastructure, that's where Platform 9 adds more value, right? It removes the silos that exist. So that to me is the number one area where Platform 9 creates value. Chris, I don't know if you have other thoughts on this.
Sure. I think there's also a question you need to ask when you're sort of architecting your new environments, and whether or not you're always going to be in a single cloud, or if you're going to have any edge deployments that are running on bare metal, and being able to create a consistent experience across all of those from an operations and from a development perspective as well. You mentioned AWS specifically. Within AWS, we have two ways of assisting. One is what we will call an AWS cloud native cluster, where we deploy and operate a upstream Kubernetes cluster on whichever version you choose, be it 17, 18, 19, soon to be 120 as well. And we'll build the control plane as well as the worker nodes out on EC2 instances. We'll bring in the load balancers. We'll handle all of the DNS routing and enable Route 53. And you have full access to the control plane layer and all of the API server flags, so you can do customization to that. as well as full access to all of those nodes that are underneath. Our support will also help with your journey to, rolling out your applications and architecting your environment. So when it comes to AWS, we're going to help stand that up. We're going to help keep it operational. Our software and our support team are going to be there to support you on that journey and support you when anything goes wrong, and proactively get in there and fix issues if we're notified of a problem within that cluster and we're able to take restorative action without requesting any interaction from yourself. So that's one way of leveraging AWS. The second way is importing your existing EKS clusters and then treating Platform 9 as the centralized location for accessing and understanding what's going on within those clusters themselves. The ability to manage and control EKS is brand new functionality for us. And it will be a growing part of our roadmap moving forward. So we'd always love to hear feedback and input on how we can improve that. So if you're in AWS and you're looking for certified Kubernetes engineers to support you on your journey to developing and running applications, then Platform 9 can really help you on that journey. And it's not just about the deploying the cluster, right? It's all about the day two operations, planning and controlling upgrades effectively, and having a team there that helps your ops team and is an extension of your organization as well.
Yeah, and I would add that all of that is obviously available on AWS and for core use cases. Sorry, there's an ambulance that went by. But all of that also extends out to RAN, right? And all of your infrastructure that's closer to the edge that I was saying earlier. The same support, the same Kubernetes experts, the same management plane for the entire deployment, not just your core.
I think that hopefully that covered the question on AWS. There's also support for Azure in there, and AKS support will be coming very shortly as well. So we're expanding out the multi-cloud operational capabilities in that place, that space as well. I'm not currently seeing any other questions come through. Ryan, do you have any more topics that you wanted to touch on?
Well, we have like a little over 5 minutes, but one thing is KubeWord, right? Mudit showed some of KubeWord, but essentially with the next release or two, we're gonna start percolating into our SaaS management plane, into the UI as well. So this might actually be a good time to just give you a quick early view into what to expect from a UI perspective as well, when we think of VMs and containers running alongside each other.
Yeah, if you've got that running, I think that would be awesome to pull up that KubeVirt environment.
I don't have it running, but I have a visual.
No, I've got a live DU. If you give me a moment, I can pull it up.
Oh, okay, awesome.
I can even Slack you the link. One second is my
Do you have VMs deployed on it?
Yeah, I'm just waiting for my my disk from I'm on a VPN. 1 second. It would appear not. I'm having connectivity issues. I think we'll go back to your screens there. You there, Ron? or have I lost everyone?
Oh man, I made the classic mistake. It's like the theme of 2020. You're on mute. Anyway, so I've been on mute for the last 20 seconds. But basically, what I was saying is that you saw in Mudit's demo how he showed you the UI and the management plane, where you have the dashboard and the infrastructure where you can view and create clusters and so on. In addition to that, with our 5.2 release, you'll see a virtual machines tab, and you can check this out in our free tier, where you can create KubeVirt VMs, and KubeVirt is fully managed. All of that support, all of the upgrades and everything is fully managed by Platform 9. You can come here, create VMs, in as a part of your Kubernetes clusters. You can perform the operations that you would expect, like live migration, edit the VMs. We'll roll out some functionality where you can even monitor some system level metrics in Prometheus Grafana, and so on. So you'll be able to sort of manage the life cycle of VMs as a part of your Kubernetes clusters, all from the same control plane. So I would really, over our current release as well as the next release, a lot of this functionality will start maturing. And so I would encourage all of you to check it out if you're interested.
If you stop sharing for a moment, I can actually show that live and built. Oops, wrong button. Share desktop. All right, this is it. This is our actually a dedicated KubeVirt demo environment, and I'm on the virtual machines tab here. So this is pulling in all of the KubeVirt VMs running on one of our clusters. This is in early access, so a lot of features will be getting added and built out, as Rohan was mentioning. So you can come in and see the details of that virtual machine as it's running. Importantly, its IP address and Ethernet configuration, really important for gaining access to a VM. To deploy a VM right now, we're sticking with the tried and true YAML approach. We will be expanding this out, as you saw in the mockups that Rohan has. Just to go back to the environment that's running here, there's 4 clusters. And there is a KubeVirt cluster running here with SIROV enabled. You can see there's an upgrade available. That's an upgrade to 120, I believe. So all you'll have to do once this goes live in the next 2 weeks is sign up for free tier, come in and create a cluster. And during that create process, you'll be able to enable KubeVirt, which will then enable this dashboard to render and be live. Then once you come in and click new virtual machine. And I believe within our docs, we've got some examples of how to deploy some VMs.
We'll have them coming out with 5.2, but yeah.
Excellent. I'm going to click stop share, go back to questions.
And all of it, just to add there, all of it is, really just open source upstream KubeVirt. And so a lot of the ecosystem also ends up mattering. There are lots of examples out there on the internet beyond our documentation. There's a whole community that's developing this and releasing pretty quickly at the moment. So there's a lot going on. It's pretty exciting. And we're using the upstream version.
Excellent. I think there's one last question that I think Vidit should touch on that he's also replied to about RAN.
Chris, actually, I have one slide even to answer that. So maybe let me quickly share my screen and show that. So just do that slide maybe. So the question was where we run RAN or where we run. So this slide actually gives that answer. So we are what we are saying is you can have a far edge clusters which could be maybe running onto the cloud or very near to the customer premises. So that is where you have these far edge clusters. Then you can have the edge clusters and actually the core. So it could be residing into the customer premises, where we deploy all this code. And all these clusters is managed by Platform 9 management plane. So you get from the single management plane, you can manage all these thousands of clusters. So you can deploy these clusters, you can manage it, you can manage all the applications from single pane of glass.
Excellent.
So I hope I answered Moonika's question. Over to you, Chris.
Yeah. Excellent. There's one other question that's come in that says, in your opinion, does it make sense to connect Kubernetes networking with SDN approaches and SDN controllers? I think that's a good question. We are at the top of the hour. Just to touch on that quickly, some of that will depend on the CNI. Our preferred CNI that we own and operate for all of our users is Calico. Calico can be deployed in its native BGP deployment configuration, which then means you can use external peering and access to pod IP addresses directly as well. So I know it's not the answer to the question specifically. I think maybe our next AMA we can dive into networking in more detail. There's definitely different mechanism. It's going to come down to, where are you deploying, what's currently running there, and how do you want to access the resources within that cluster. So physical or software-defined load balancers come into it. Do you want to use BGP or encapsulation within the network space for Kubernetes as well? So there's lots to explore there, and I think we should put that as a question to touch on in a future AMA on networking. And with that, I would like to thank everyone for dialing in. Some great questions, great engagement from everyone that joined. So thank you very much for your time. This will be recorded and posted to our YouTube channel for future references. If you want to get going, just head to platform9.com and sign up for our free platform. It's free forever. If you want to get in contact with any of us, feel free to reach out to Platform 9 or find us on LinkedIn as well.
Thanks, everyone.
Thanks, everyone. Thanks for joining.
Thanks.